So, okay, here is in fact the control center for the inverter, and you can see here we've got which is a toggle, so we're showing 25.2 volts. The difference is the voltage drop on the cable. The thicker the cable from the battery, the heavier the cable from the battery, the less the volt drops. It's always good to keep that cable as short as possible. This cable is a little bit long, and it was done like this because we were trying to show a demonstration of the equipment rather than an actual. So this is actually a demonstration of the unit rather than an actual installed unit, even though it's all fully functioning and it's powering the power for the office and stuff. So you can see on here we've got 25.25 volts. We've got the AC voltage, which is 232, and we've got the current loading, which is the wattage it's delivering. So you can see the three. In fact, it's actually showing on the inverter 363 watts. We're showing on our meter 363 watts. So they're both meters concur, so they're both accurate. Even this little thing here is giving the same information. Right, we press the button in here, and we've got a number of screens. We're showing the charge current. The charge current, this unit has a built-in battery charger where it can be used as a UPS. So if you're using the unit without solar panels, where you might want emergency power, so you've got electricity during the day, but you have power outages, then you use this to charge the batteries. You don't need solar panel. Of course, solar panel is cheaper, but this can actually charge the batteries at 10 amp. So this is showing the charge current. As we're powering from the solar panels on the roof, then it's very little. Goes with the next function here. Right. So it just toggles between the three. You can see the toggling through the type. AC, charge current. Okay, now to program it has some programming features. To go into the programming mode, you hold this button down and for a number of seconds, and it goes into programming mode. So you'll see the first one, AC charge level. This is the charging circuit. We're not using the charging circuit, so we can ignore this. The next thing you see is phase tracking. Phase tracking is just basically means depending on the power level, depending on the power of the batteries and stuff, then it will vary the charge current when there's phase relating to power. So I'll hold it down. I'm talking too long. So on to the next setting. So grid fail safe. Grid fail safe is a beeper. If the grid fails, it goes beep, 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 beep. That's all that is. Clear power time. Clear power time is the unit has a recording, and it records how much it's been used, like an odometer on a car. Later on we may change this so it can't be deleted, but at the moment it's like a trip. We'll put one set permanent, so it records how long the units work for and how much power it's produced. So this has a recording. I have to keep holding the button again to go into the charge. So backlight. Backlight is simply the backlight that lights up the LCD, period. That's it, nothing else. Okay. Standby power mode. Now I'll go into that in a second. Right, it has normal or load seeking. I'm going to change this to load seeking. And I'll press enter. The power's gone off. Watch a second, we've lost power. It will come back on again. What it's doing is it's looking for a load. There we go, we're back on. So now, when there's no load, when everything is switched off, the inverter shuts itself down. It's very clever. Saves the battery on the power. So everyone's all gone home, you all gone to bed. What's the point in burning a couple of amps or whatever off an inverter that's not doing anything? So the thing actually shuts itself down when there's no load. So it's load seeking. Fantastic if you're using for say for example on a boat or something like that, or anywhere where you're remote, or you're totally off